Okay, so we'll go through these sequentially. What the idea is that I have given you one of the different forms. So I've filled in one of the different boxes, and you have to fill in the other ones, right? So let's start here. So I've given you a complex number in Cartesian form, 3 plus 4i. The idea is that I want to convert this into polar form, Euler form, figure out the modulus of the argument, and also have a go at sketching the Argan diagram. So I think first of all we should start here, because if we have the modulus and argument, it's very easy to put it in polar and Euler form, right? So does anybody want to suggest how we calculate the modulus of 3 plus 4i?
Basically find the triangle hypotenuse.
Yes.
In English, that's it.
Yeah, exactly, hypotenuse. Yeah, that's fine. So yeah, so we have a right-angled triangle effectively, where we can say that is 3, and then the 4i will be the imaginary component, so we can call that bit 4, right? So the modulus, remember, will be this bit here, so we can call that r if you like. So that's the modulus. So just use Pythagoras, yeah? And obviously that's a nice Pythagorean triple, hopefully you realise, but if you wanted to, square root of 3 squared plus 4 squared is equal to 5, yeah? Cool. There we go, there's 5. Argument then, how do we calculate that argument? How do we calculate that angle in there? Yeah, cool, excellent. So it's just going to be the tan inverse of 4 over 3. Did we get an answer for that?
Yeah, 0.92.
Okay, and is that in radians as well?
Yeah.
Yeah, perfect. So just remember when you're dealing with complex numbers, they need to be in radians, right? So actually from here, it's relatively easy to find the polar and Euler form, right? Because if you remember, the polar form is just going to be my r, which is 5, times by the cosine of my argument, plus I sine of my argument, right? And obviously there's an extra bracket on the end there as well. Okay, so that's polar form. Euler form, also very, very familiar to us. It's just 5, so my modulus, e to the I times by my argument, right? So 0.9292, lots of I. Sorry, that's a terrible 9. Try that again. There we go. And if I want to have a go at sketching this, right? Well, actually, I could probably sketch it more easily thinking about the Cartesian form. Because 3 plus 4i just simply means I move 3 across and then 4 in the imaginary direction, right? So in fact, if I just sketch the positive quadrant of my Argan diagram, so that's real, that's my imaginary, I can just literally say I move 3 units across and 4 units up. So it's going to be about there somewhere. So if I call that the complex number z, so I can obviously mark on 3 there, oops, 3 there, and 4i. If I wanted to mark on the modulus, I could mark that as 5, and my argument is 0.92. Happy with that?
Yeah.
Any questions? Cool. So really this is just a bit of practice being able to convert between any of the forms. It's just becoming fluent with converting between them. It will become important with what we're going to be looking at today to be able to convert between Cartesian and a modulus argument form, so either polar form or Euler form, right? Hence the reason why I'm doing this activity now. All right, great. So this one here, we've been given the Argan diagram, and we have to get the modulus argument, Cartesian form, etc. from this. Now, from the diagram, you're happy you can just read off what the modulus and argument is, right? So what's the modulus going to be? Yeah, square root of 2. And the argument? Great, pi by 4. Okay, so actually I'm going to skip Cartesian form for the time being, and I'm going to find polar form and Euler form because I've got that modulus and argument, right? So I can say that's root 2 times by the cosine of pi by 4 plus I sine of pi by 4, like so. And Euler form, I can say that's root 2 e to the pi by 4 lots of I. Now how could we figure out Cartesian form then?
In this case, pi by 4 is halfway between
Yep.
upwards
Yeah.
from x-axis, so it would be equal y and x.
Okay, so you're thinking about that right angled triangle, yeah? That's right, that's fine. So yeah, you've got that right angled triangle there. You know that's pi by 4. Well, obviously, because it's right angled, that's pi by 2, that's pi by 4. Or if you want to do it in degrees, it might be slightly easier to think about. 45 degrees, 90 degrees, that's got to be 45 degrees or pi by 4. So you're absolutely right, it's isosceles, yeah?
X and y are the same values, just need to find them.
Exactly. So you know these two values are the same. So if you want to call it x and x, that's totally fine. So you can say x and x, right? So if you just use Pythagoras on that, you can say that x squared plus x squared is equal to root 2 squared. Yeah? So that would be 2x squared is equal to 2, which means that x squared is equal to 1. Okay, well x is just got to be equal to 1. Yeah? So actually in this case it's nice and easy because you can literally just say it'll be 1 plus I. Yeah? Now that's fine because in this particular instance it was relatively easy to work out, right? Because we had that pi by 4 that we could recognise that it was isosceles, which is great. How else, or more generally, how do we convert between a polar form, Euler form or Cartesian form?
I think you use sin or cos and you apply the argument in it. It's going to give you the cos is for x, I don't know, and
Yes.
sin is for y, and it's going to give you your, not saying your values, but
Absolutely.
it gives
Okay.
you your position. I don't know how to say it.
Exactly. No, I kind of understand what you mean. So in other words, if we expand this out, we could write this as root 2 times by the cosine of pi by 4 plus I times root 2, rather, times the sine of pi by 4, right? So that's just expanding out that root 2. Now, recognizing the fact that Cartesian form has to be of the form x plus iy, are you happy that you've literally got that here? That's my x and that's my y, right? Because it's a bit times by the imaginary part. So actually, if you just type into your calculator root 2 times by the cosine of pi by 4, you get 1. Can you just verify, John?
The round form, right?
Yeah, exactly, and the same for that one as well. So that's also 1. Does that make sense?
Yeah.
Yeah, perfect. So in general, if you want to convert between polar form or Euler form and back into Cartesian form, you just remember the fact that you just think about the polar form, multiply it out, and you've got your x and your y if you just type in your calculator, right? Now, I'm not always promising it's going to come out as nice, round, exact numbers like that, but, you know, we'll do more practice down here anyway. Okay, great. Let's have a look at this one then. So let's go for Euler form first. Well, actually, first of all, let's find the modulus and argument because it's there, written in front of us, right? So what would the modulus be? 7, and the argument?
3 pi over 2.
Excellent, 3 pi over 2. Now, just using that, let's find the Euler form. Anybody want to suggest what the Euler form is going to be?
7 e to the power of 3 pi over 2 I.
Excellent. Yeah, perfect. Okay, I think we could actually do Argan Diagram at this point, right? Because we've got all the bits that we need. So let's worry about the 7 in a minute. 3 pi by 2. Think in terms of degrees. How many degrees is that?
270.
Good, 270. It's basically 3 lots of 90 degrees, 3 lots of pi by 2. So in other words, because the argument is always measured as the angle that we move through anti-clockwise from the positive real axis, it means, let me draw it in. So this is real, this is imaginary. In other words, what we've done is we've moved through 270 degrees, or 3 pi by 2 radians, to get around there, right? So in other words, we're sitting on the negative imaginary axis, and because we know that the modulus is 7, it means that the distance from the origin must be 7 units. So if we're going downwards, are you happy it's going to be negative 7i? Does that make sense? So we just literally moved through 3 pi by 2. We figured out we were on this imaginary axis down here. This 7 just means that we've moved through 7 units from the origin. So if we're moving on this axis, and we have to be moving downwards on this axis, because we move through 3 by 2, then we must mean that we're 7 units from the origin. So the only way that can happen is I, because it's on the imaginary axis, and it's negative because it's downwards. Yeah? All right, nice. Okay, so let's go for Cartesian form then. So we could probably just use this, right? So the Cartesian form, let me just write the working in. So the x will be 7 times by the cosine of 3 pi by 2. And the y, the real component of the imaginary part, will be 7 times by the sine of 3 pi by 2. Okay? Now in this case, it's not actually that hard because you can just see it from the diagram, right? You're not moving any left and right, so it'll be 0. So there's nothing in the real direction, but there's 7 in the negative imaginary direction. So you could just write that as 0 minus 7i, or just negative 7i if you prefer. That's fine. Make sense? Cool. Let's finish this one off then. Okay, so here we've been given Euler form. Let's find our modulus and argument. So what's our modulus? Good. Root 3. What's our argument? Negative pi over 6. Good. So let's find our polar form. Anybody want to give it out?
Square root of 3.
Good. Thank you. Yep.
Minus pi by 6.
Good.
Sine, I sine,
Good.
minus pi by 6.
Excellent. Yep. Well done, Ibrahim. Thank you, Jean Sebastian, as well. Great. Okay. Makes sense? Good. Let's think about this then. Now, just remember that the argument is the angle that we move through anti-clockwise from the positive real axis. So if we stick a negative in front of it, what do you think that means?
Clockwise.
Good, go the other direction, right? So pi by 6, that is, what, 30 degrees in degrees? So if you think about it, if I just draw my Argan Diagram in, so this is my real, this is my imaginary. Because I'm moving in the clockwise direction by pi by 6, I'm going to end up with an angle sort of roughly about there. Make sense? Good. And obviously my modulus is root 3. Okay? So let's find our Cartesian form. Now this one, I think we're going to have to actually plug in the numbers into a calculator. Here it's just a little bit more awkward, right? So, or maybe you could use trig with this triangle. That's also fine as well. Yeah, I think it's probably easier to do a calculator. So let's do root 3 times by the cosine of negative pi by 6 for x. And then y will obviously be root 3 times by the sine of negative pi by 6. Obviously, it's not too hard actually to do it in a trigonometry, but I think it's just easier to do a calculator. Yep, okay. 0.5i, obviously. Yeah, great, okay. Good, thank you very much. All right, let's have a go at this one then. Let's finish it off. So this time, being given the modulus and the argument, we have to find the relevant forms, right? I'm actually going to start off over here with the Argan diagram. So if I just quickly draw that in, then I'll shift out the way. So, okay, 5 pi by 6, well, that's going to be 5 lots of 30, which is 150 degrees, basically. So we know roughly where we're going to be. We're going to be out here somewhere. Okay, so that's going to be my 5 pi by 6. So I'll crouch down and then hopefully you can get the idea. And then the modulus is 13. Okay, so that would be my Argan diagram. Okay? All right, let's do the polar form and the Euler form first, because then we've got the modulus of argument. We can go back and convert to Cartesian in a second. So, are you happy? The polar form will be 13 times by the cosine, I'll put it all in a bracket, cosine of 5 pi by 6 plus I sine of 5 pi by 6. And then Euler form, nice and straightforward, it'll just be 13 e to the 5 pi by 6i. Happy with that? Yeah. Okay. And again, just using our x being 13 cosine of 5 pi by 6 and our y being 13 sine of 5 pi by 6. What do we get for our x and our y in our Cartesian form? Just 3. Yeah, it should be negative 3 because it's over on the left-hand side. So 13 cos of
Let me see.
5, 5 or 6.
6.55.
Okay, so negative 11.25 plus 6.55i. Great, thank you.
Which makes sense.
Yeah, exactly. It kind of looks reasonable. Always check on that Argan diagram. It's always good if you don't draw it, at least just to have it in the back of your mind, kind of figure out which quadrant you're in, and then you can kind of see whether you've got, roughly the right numbers there. Okay, are there any questions about anything that we've done there?